Hey students, back here for another video. This one is going to be on moles. And moles is a big topic we've talked about before. And we've been using two different methods of approaching moles. One is by using these tools on the left here, or conversion factors, where they're all equal to 1 mole. And depending on what we have and we want to go to, we'll use these different conversion factors or tools. But also, you've seen Mole City, and Mole City is also something maybe you're using, where it's sort of a diagram of how to sort of roadmap your way to the answer. Um, both have benefits and drawbacks, but you probably at this point are pretty comfortable with one or the other. And I would say stick with something that you're comfortable with, and really make sure that you understand that one. But I'm going to use both of them in solving problems to help you kind of see this. All right, so we'll start off with something pretty straightforward for moles. Let's say the question is, how many moles of zinc are in, let's say, 150 grams zinc. Okay, so in this question, you're going to write down, like the previous video, right, grams, and you're going to be solving for moles. Now, you always should give yourself enough room because you might not know exactly from the beginning, like how many steps until you write it out. So give yourself enough room to solve these problems. But with these, like we did in the previous video, you are going to use the factor label method. It's really helpful because you get to see that you are moving from one unit to the next in different steps, and that way is also kind of showing you that you're doing it correctly if you set it up so that your units are crossing out and you're moving closer to the unit that you need. Okay, so in this case, you have grams and you have moles. Given grams, finding moles. And so we'll look at first the left-hand side. So here we have a tool or a conversion factor where we have moles equal to molar mass, which is in grams. So this is what we're going to do. We're going to use that one. Okay. Now, if you are doing the opposite, where you're doing the mole city, this would be like starting in Granville and going to Mole City over here. Okay. So that gives you the indication of what you're going to do there, right? In this case, you are going to, as it says, divide by the molar mass. Now you might be asking yourself, what the heck is molar mass? Molar mass is the mass of a particular element or molecule, 1 mole of that thing. So if you have 1 mole of zinc, right, the molar mass is the mass of 1 mole of it. Now, these numbers are not something you have to memorize. They are the decimal that's underneath the chemical symbol on the periodic table. And so when we go to our periodic table and we find zinc real quick, we'll see that zinc, as you can see here, is 65.38. That means that it's 65.38 grams per mole. So I have grams multiplying here, so I'm going to divide by grams. Okay, that molar mass there. And this is a molar mass, meaning the mass per 1 mole. So my conversion factor is 1 mole for that mass. Always 1 mole when you're doing molar mass. Okay, and then we solve. And we can solve this because we've now crossed out our grams and we have moles. So 150 divided by 65.38 point, oops, 6.38 equals, and that would be 2.29. Okay, and that would be the number of moles of zinc. Again, you can use the factor label method, right, and set it up like that. Or with Mole City, you have an image there that sort of tells you if you're going from Granville to Mole City, that you would go and divide by the molar mass. Okay. All right. Let's try another one. Okay. So let's try something a little bit more interesting. What if we had, if you have 1.2 times 10 to the 24th molecules of H2O, how many grams do you have of H2O? Okay? If you have 1.2 times 10 to the 24th molecules of H2O, how many grams is that? So we're going to set this up as we always do. Put what's given to you on the left, and this is molecules of H2O. And what we want to get over on the right, which is grams of H2O. Okay. Now, we'll start as we've done before, looking at the conversion factors on the left. If we look at what's given to us, I see that we have molecules here. So I'm definitely going to be using this. It's the only one that has molecules in there. But it's equal to a mole, and I don't want to go to moles, I want to go to grams. So what this means is I'm going to have to use two different conversion factors. Okay, I'm going to start with the first one and then use the second one. Okay, so I'm going to set this up so that I have two fractions. Now, going over to Mole City for a second, I see that I have, I don't know where my star went. I see that I have my molecule, so I'm in molecule town over here, and I'm going to go to grams, so I'm going to go from molecule town to Mole City and then to Granville. Okay, and it tells you on the arrows what we do. From molecule town to Mole City, you're going to divide by Avogadro's number. And that's exactly what the first tool says as well. You're going to divide. Why? Because molecules are being multiplied by this fraction. So it means I'm going to divide by 6.2 times 10 to the 23rd. Why? Because I want to get rid of molecules. And then I'm going to put this out of 1 mole. That's what it says here. And that's the number of atoms or molecules per mole. Now, I can cross out because I have molecules and molecules, and I'm in moles, but I don't want to get stuck in moles. I want to keep going. Right? For Mole City, right? It is now in Mole City, we're going to go to Granville. That means multiply by molar mass. Also, same thing down here with the conversion factors. I'll write 1 mole. As it says, molar mass. We're going to multiply by it. And this is water. So what's water in terms of molar mass? Molar mass of water, go over to the periodic table. Hydrogen is 1.008. Oxygen is 15.999. And so we can add those up. We have 2 hydrogens, right? So 2 times 1, just for simplicity's sake, plus 1 times 16. And what we get is 18 grams when we add those up. Okay, just to clarify. All right, so now we are set up and we just multiply and divide. So we can cross out moles and now we know that we have grams. So we take 1.2 and divide it by 1.2 times 10 to the 24th divided by 6.02 times 10 to the 23rd. I made this relatively easy for me because it's a little bit hard for me to use the computer calculator with exponents. So this is actually twice as much. If you plug it into your calculator, you'll see that 1.2 times 10 to the 23rd divided by 6.02 times 10 to the 24th to the 23rd, that's going to be 2. And 2 times 18 is 36. Okay, and that's how many grams of water is in 1.2 times 10 to the 24th molecules of water. Okay. All right, let's try one more. So let's get into a little bit of the gas station down there. Now the gas station is only for gases. So if we're not talking about gases, if you notice that the problem talks about a liquid with a little parentheses L next to the molecule or the element, then you're not talking about gas station. You're not talking about Avogadro's volume, which is 22.4 liters. So you can't use that bottom conversion factor either. But if you are talking about a gas, then you can. That does come into play. So let's use one example here and run through an example with that. All right, so let's say that we have you have 250 liters of N2 gas. How many grams is that? Okay. All right. So in this case, you have 250 liters of N2 gas, and I want to get to grams. Okay. So in this one, we're seeing that we have a gas, so we know that we can use, if we need to, the last tool. And yes, it's in liters, so I'm going to be using this. And I'm not going into moles, so I can't just stop there. I have to go to grams, actually. And so the only other step that has grams is the middle one. And so I'm going to use that one second. Okay. Now, again, with your mole city, you would start down here in gas station. You would go to mole city, and then to get to number of grams, you go to Granville. So you go like that. So you divide by 22.4, and then you multiply by the molar mass. Okay. All right, to write this out, you're going to have two steps. We have liters on the multiplying, so we're going to divide by liters to get rid of them, 22.4 of them to be exact. That's equal to 1 mole. Now, I can cross out my liters, and I'm in moles. Now, the next fraction is the second conversion factor, and now I have moles multiplying on top, so I want them down on the bottom to get rid of them. This conversion factor is 1 mole equal to the molar mass. Well, what's the molar mass of N2? Well, let's take a look. N2, nitrogen. Nitrogen is 14 grams, and there are 2 of them, N2. So that means it's 28 grams of nitrogen for every 1 mole. I can cross out my moles now, and I'm left with grams. Beautiful. So I take my 250 and I divide by 22.4, and then I multiply by 28, and I'm left with 312.5. 312.5. That's how many grams. Okay. Now, I just did 3 problems. One was a 1-step, and the other ones were 2 steps. There are a couple of different, if you look at the worksheets, there are a couple of different, maybe curveballs, I guess you could call them, right? Where you have, maybe you have a density, for example, right? And let's say it's a density of, water, right? Let's say you have, 200 milliliters of water, of H2O. And this is a liquid, so it's in parentheses. And they want to know what is the number of moles. So you might be tempted to go right to the bottom one, but remember the bottom conversion factor and gas station. This is not a gas, it's a liquid water. So there's another piece of information that you want to remember. For every 1 milliliter of water, it's equal to 1 gram, okay, of water. It's only for water, okay? So I can convert my milliliters directly to grams. So 200 milliliters is equal to 200 grams. You could just write that out, okay? So once I have grams, now this becomes a normal mole problem where I have grams and I want to go to moles. What do? I divide by the molar mass. And we already, discussed what the molar mass of water is. It's, 2 hydrogens, each being 1 gram, and oxygen being 16, so that's 18 grams for 1 mole. Okay, so that would be, 11.1 of water. Okay, so that's one way of challenging you. Another way of challenging you is by giving you a density and saying that there's a gas here. So, if we write that we have, and this is not going to be accurate, but 1.3 for, grams per liter equals the density of Cl2. I'm just making that number up. I'm not sure if that's actually right. And so, they might ask you something like, you know, um, how many atoms, or sorry, molecules, in this case it's Cl2, molecules is this? Is actually, I can't do that. You might say, trying to think of a way of asking this question. If you're getting the density, if you're given the density, can figure out like what's the you would do 1.34 grams per liter, and then this is a gas, so it would be 22.4 liters per 1 mole. And this gives you grams per mole, so you can get the molar mass of it. That's one way of getting the molar mass of it without having any other information. All right, so it's 1.34 times 22.4. Again, I'm making this problem up, but you can use, again, don't get confused by the density. If it's a gas and it's grams per liter, then you can use 22.4, right? 22.4 liters per mole. So you can convert from liters to moles there. Okay, that's just one more example. I hope this was helpful, and stay tuned for the next video.